Hey, there. Have you ever scrolled through a website and thought, how did they do that? Or maybe you felt overwhelmed trying to keep up with all the different programming languages out there. Well, today's deep dive is for you. We're going to break down the fundamental concepts of programming languages and give you a mental model to understand how it all fits together. It's like learning the language of the digital world. Once you understand the basic grammar, you can start to appreciate the nuances and even the artistry of how software is created. Let's start by mapping out the territory. When it comes to programming languages, there are key distinctions. Some are like meticulously following a recipe, while others are more like jazz improvisation. We call these statically typed and dynamically typed languages. Statically typed languages like C++ or Java require you to define the type of data a variable can hold up front, and it can't change. It's like telling the computer this variable is a container for numbers only, no switching to letters halfway through. It's all about setting those ground rules from the start. The advantage? Statically typed languages offer efficiency and catch errors early on. The compiler checks for type errors before the program even runs, like making sure you haven't accidentally put salt in your cake batter instead of sugar. On the other hand, dynamically typed languages like Python are more flexible. You don't have to specify the data type beforehand, the interpreter figures it out as the program runs. It's more like improvisational cooking, where you can add a pinch of this or that as you go, and the dish still comes out delicious. This flexibility makes dynamically typed languages popular for rapid prototyping and data science, where you often work with data that can change form on the fly. Within the static versus dynamic landscape, there's also the difference between compiled and interpreted languages. Compiled languages are like translating an entire book into another language before you can read it. Interpreted languages are more like having a real-time interpreter whispering the translation in your ear as you go. With compiled languages, the whole code base is converted into machine code all at once, which is what the computer actually understands. This makes compiled languages super fast, often used for performance-critical applications like game engines or operating systems. If you're building a high-speed racing game, you might reach for a compiled language like C++ to squeeze out every ounce of performance. Interpreted languages are translated line by line as the program runs, making them a bit slower but also more portable. You can run them on any machine with the right interpreter installed, offering a trade-off between speed and versatility. Compiled languages are like cheetahs, blazing fast but a bit more specialized. Interpreted languages are more like camels, not the fastest, but adaptable to different environments. Within interpreted languages, we find Python again, known for its beginner friendliness and incredible versatility. We've mapped out static versus dynamic and compiled versus interpreted. Now, let's zoom in on HTML, a special case. HTML, or Hypertext Markup Language, tells your web browser how to display content. But it's not a programming language in the traditional sense. It doesn't instruct the computer to do anything, it uses tags to define the structure and content of a web page. Think of HTML as the architect's blueprint for a house. It lays out the structure, where the walls go, where the windows will be, but it doesn't build the house. HTML provides structure and meaning to web page content, used alongside CSS for styling and JavaScript for interactivity to bring web pages to life. It's like designing a car versus building the engine. HTML gives you the design, and languages like JavaScript provide the horsepower. Speaking of dynamic, let's talk about libraries. Libraries are game changers, especially for languages like Python. They're like pre-built toolkits for programmers. If you're building an app that needs to analyze user data, you can import a library like Pandas instead of writing all the code from scratch. It's like having a whole library of code at your fingertips, making Python popular in fields like machine learning and data visualization. Libraries are constantly updated and expanded by the programming community, fostering collaboration and innovation. This shared knowledge allows us to build increasingly sophisticated software. It's like open source software, where everyone contributes to make something amazing. Finally, there's the matter of organizing all this code, especially in large-scale projects. That's where object-oriented programming, OOP, comes in organizing code by creating reusable objects. Imagine you're designing a video game with different enemy types, each with unique abilities and behaviors. With OOP, you create a class for each enemy type, containing all related code, and create new instances as needed. Classes can also inherit properties and behaviors from other classes, creating a family tree of code. It's a remarkably efficient way to manage large codebases. Instead of having lines of code jumbled together, related code is grouped into neat objects, making debugging easier. Understanding these concepts connects everything from language types to OOP, offering an elegant way to manage complexity. Just having this basic understanding makes you a more informed technology user, appreciating the engineering behind software. As we wrap up, remember, programming languages are tools, each with strengths and weaknesses. Understanding these concepts empowers you to choose the right tool and marvel at the creativity behind the digital world. Whether building the next killer app or navigating the digital landscape, understanding how it all works offers a new level of appreciation. It's like having a superpower, the ability to understand technology's language, possibilities, and limitations. Keep exploring, asking questions, and diving deep into the fascinating world of programming. You never know what amazing discoveries await. Until next time, happy coding, or if you're like me, happy code appreciating.